Welcome to the Deep Dive. We plunge into complex topics, try to bring you the clearest, most fascinating insights. And today we are exploring a secret that's, well, it's literally out of this world. Picture this. A miniature space shuttle. But it's robotic, totally uncrewed, and it's wrapped in so much secrecy it really sounds like something straight out of a sci-fi blockbuster. We are talking about the X-37B, our mission today. Let's try and unravel the enigma of this U.S. military spacecraft. We'll dive into that. A barrage of theories about its purpose, explore the wider world of reusable space hardware, which is just as fascinating, honestly. We're going to get you informed quickly about what might really be happening with this shadowy craft and the cutting-edge tech behind it all.
Yeah, it's absolutely true. The secrecy around the X-37B is incredible. And that level of secrecy, it naturally sparks a lot of curiosity and, let's be honest, some pretty wild speculation. But what's fascinating, I think, is that while, yes, many specific details are classified, the basic laws of physics and engineering, they can actually tell us quite a lot about what it can do and, maybe more importantly, what it can't do. It really is a remarkable piece of engineering, though, really pushing the boundaries.
Okay, so let's peel back some of those layers then, this intriguing piece of hardware. Can you walk us through the basics? Like, physically speaking, what is this miniature space shuttle?
Sure. So it's built by Boeing. It's reusable, robotic, quite compact, actually, about 29 feet long, 9.5 feet tall, with a wingspan just under 15 feet. So yeah, imagine the space shuttle, but, scaled way down. And critically, it's totally uncrewed. It does have a payload bay, though, roughly 7 feet by 4 feet. People often say it's about truck bed size.
Truck bed size, okay.
Yeah.
Gives you a good visual.
Yeah.
And how does it get up there? And what about coming back? That's the really unique part, right? The return trip.
Right. It launches vertically on top of powerful rockets like the Atlas V or, more recently, the SpaceX Falcon Heavy. Standard stuff there.
Yeah.
But the really impressive bit, the thing that makes it truly reusable, is the landing. It comes down and lands autonomously on a runway.
Just like the shuttle used to.
Exactly. Just like its human-piloted predecessor.
Yeah.
That autonomous landing is key. And, you mentioned unique features. Its longevity is definitely one. It was initially designed for maybe 270 days per mission.
Yeah, something like that.
But it's routinely blown past that. OTV-6, its sixth flight, it set an incredible record, 908 days in orbit.
Wow. 908.
Yep, that's about 2.5 years. And across all 7 missions so far, the X-37B program has clocked over 4,200 days in space.
That's more than 11 and a half years total, just orbiting.
Exactly. That kind of endurance in a reusable vehicle, it's really groundbreaking stuff.
Absolutely astonishing. And speaking of things that add to the, let's say, the mystique, I've heard the ground crews wear these protective suits. They look a lot like spacesuits. Why? If they're just on the ground. It sounds very dramatic.
It does look dramatic, doesn't it? But it's not for show, believe me. It's purely about ground safety. See, the X-37B uses these highly toxic hypergolic propellants, nitrogen tetroxide and hydrazine. Nasty stuff.
Hypergolic meaning they ignite on contact.
Exactly. No ignition system needed. But they're dangerous. After the vehicle lands, there's a risk of hazardous fumes from any residual propellant. Plus, the heat tiles themselves, after screaming through re-entry, they can outgas some dangerous substances, too. So those suits, absolutely essential to protect the technicians. It's less sci-fi glamour, more hazardous materials protocol.
Okay. Makes sense. Less exciting, maybe, but definitely important. All right, so we have the basic facts. But the real enigma, the fun part maybe, comes when we look at the theories about its purpose. Officially, the Air Force, now Space Force, says it's an experimental test program, demonstrating tech for a reliable, reusable, uncrewed space test platform. Sounds reasonable,
yeah.
But that hasn't stopped the speculation, has it? So it's theory number one, the big one.
Oh, that's got to be the space bomber theory. The idea that it could be some kind of hypersonic vehicle swooping down to deliver munitions anywhere on Earth in, 2 hours.
Right, the super dramatic Hollywood version. But does the science actually back that up? Is it plausible? A space bomber?
Well, Mark Lewis, who used to be the Air Force chief scientist, pretty credible source, he basically says, forget it. He explains that changing a spacecraft's orbital plane, shifting its path significantly, it takes an immense amount of fuel. There's basic orbital mechanics. His quote is pretty direct. If I can't get my alleged bomber to the right location to release its bomb, what good is it?
Can't argue with physics, I guess.
Pretty much. The fuel requirements make it impractical as a rapid response bomber.
So if it's clearly not a bomber, from a physics perspective, where does that persistent theory even come from? Is it just, public imagination running wild? Or maybe misinterpreting something it can do?
It's likely a mix of things. You've got the intense secrecy, the military connection, the general public fascination with, powerful secret tech. It all feeds into these grander, more dramatic ideas. And I mean, technically, any vehicle that can maneuver in space and return could carry something, but the practicality for a fast, precise attack is just not there.
Okay, so space bomber. Probably not.
Hmm.
What about theory number 2 then, the spy plane idea? That one seems to have a bit more staying power. There were even claims, weren't there, that it was spying on the Chinese Tiangong space station.
Yeah, that rumor floated around. But Brian Whedon, he's with the Secure World Foundation, former Air Force guy, he threw some cold water on that one too. Based on orbital mechanics, again, right ascension specifically, he pointed out their orbits only really cross at 2 points. You can't do constant surveillance like that. So acting as a dedicated stalker of Tiangong? Probably not.
Okay, so not a stalker.
However, Whedon does acknowledge that civilian satellite trackers, these dedicated amateurs, they spotted some missions, like OTV-2 flying over places like Iran, Afghanistan, Pakistan. So is it plausible that its secret payload could be gathering intelligence data from those regions it passes over? Absolutely. That fits.
Right. So maybe not tailing one specific target, but its path suggests it is positioned for intel gathering over certain areas of interest. Does that mean the whole official experiment story is just a cover? Or are those two things, experimenting and gathering intel, actually linked?
Oh, they're almost certainly complementary. Think bigger picture. The X-37B is perfect for testing out components, sensors, systems, materials for future intelligence satellites. Especially low-altitude ones. If you fly lower, you can use smaller, cheaper optics to get the same image resolution. That lets you build constellations of smaller, more resilient spy satellites. So testing those components is an experiment, even if the goal is better future spying capability. The lines blur there.
That makes a lot of sense. Which brings us neatly to the official line, maybe the most revealing theory after all. It's an experimental platform. The official purpose is testing reusable tech and, crucially, operating experiments which can be returned to and examined on Earth. What kind of experiments are we talking about? And why is that return to Earth part so important?
This is likely its core mission, yes. And that return capability is the killer app, really. It's unique. It lets you test technology in the actual harsh environment of space radiation, vacuum temperature swings for a long time, and then bring it back for detailed hands-on analysis. You can't do that with a regular satellite. It just stays up there until it dies.
So what has it tested?
All sorts of things. For example, it tested an advanced electric propulsion system, an Aerojet Rocketdyne Hall effect thruster, more efficient maneuvering in space. It flew NASA's METIS-2 experiment package that looked at thermal control coatings, new types of printed electronics, radiation shielding materials, all critical stuff for future spacecraft, military or civilian. It even studied how radiation affects seeds.
Seeds? Like plant seeds?
Exactly. For future long-duration missions, maybe Mars trips or moon bases, thinking about how we'd grow food.
Wow, space farming, that's unexpected. It's not just military hardware, it's basic science for our future in space, too.
Absolutely. And there's more. The Naval Research Lab had a really cool experiment called PRAM on board, Photovoltaic Radio Frequency Antenna Module. The idea is to convert solar power collected in space into microwave energy and beam it down to Earth.
Seriously, space-based solar power beamed to the ground.
That's the long-term goal they're exploring. Huge potential, if they can make it work efficiently. Plus, it's deployed smaller satellites, like Falcon Sat 8, which carried experiments designed and run by Air Force Academy cadets. Great hands-on training. And on the 6th mission, OTV-6, they added a whole new service module to the back.
Expanding the payload space.
Precisely. It significantly increased the capacity for experiments, and importantly, that service module is disposed of properly before landing, following best practices to avoid creating more space junk. It really is a versatile orbital workhorse.
Okay, beyond the experiments and that incredible endurance, one of its most, maybe strategically important features, its secret weapon, perhaps is its agility. Its maneuverability. The latest mission, OTV-7, launched late last year, December 2023. It's doing something totally new, right? Operating in a highly elliptical orbit, HEO.
Yes, that's a major development. First time for the X-37B in HEO. And it's not just slightly elliptical, we're talking extreme. It goes from a perigee, its lowest point around 1,000 kilometers up, all the way out to an apogee, the highest point, of over 35,700 kilometers. That's way out there, almost geosynchronous altitude.
Whoa. What does that enable?
Well, combined with its known capability for aerobraking maneuvers, that's where it gets really interesting. Aerobraking means it can dip into the upper atmosphere, use drag to change its orbit rapidly, unpredictably. Heather Wilson, the former Air Force secretary, she famously said this ability drives them nuts, meaning adversaries, because they just don't know where it's going to pop up next after one of these maneuvers.
It's like a cosmic shell game. High-stakes hide-and-seek. That unpredictability must make it incredibly hard to track compared to, say, a normal satellite.
Exactly. Traditional satellites, they have a fixed amount of fuel. They're designed for long, predictable paths. They can't just dodge around like the X-37B potentially can. This also serves another purpose. It helps the U.S. Space Force test and challenge its own space surveillance network. How well can they track something maneuvering like this? It's a valuable training tool.
And the reusability factor plays in here too, right? Flexibility.
Absolutely. Because it comes back, they can swap things out, put in new sensors, new experiments, upgrade systems on the ground between flights. It gives it incredible modularity and adaptability for evolving missions. Unlike a satellite, you launch once, and that's it.
And this capability, this kind of maneuvering reusable spaceplane, it hasn't gone unnoticed elsewhere, has it?
Right.
I understand China has its own version.
That's right. China has its own, also very mysterious spaceplane program. It's called Shenlong, the Divine Dragon. And interestingly, it also seems to deploy objects in orbit, conduct experiments, and often its launch timings seem to sort of shadow the X-37B launches.
So a quiet space race in this area.
It definitely looks like it. A competition focused on demonstrating these advanced, reusable, highly maneuverable capabilities. Now, Space Force leaders are usually clear they don't plan to use the X-37B as an operational weapon itself. But understanding what these kinds of vehicles can do, both for the U.S. and potential adversaries like China, that's vital for planning and training.
Okay, so the X-37B is clearly valuable for testing, for experiments, for maneuverability. Let's zoom out and talk about the core concept it represents. Reusability. When we say reusable in spaceflight, what do we actually mean? And why is it considered such a big deal for the future?
Good question. Reusable means more than just designed to start multiple times. It means hardware that actually flies multiple missions, gets recovered, checked out, maybe refurbished a bit, and flies again. Think about airplanes or cars. They're reused constantly for years. That's what makes them cost-effective. The goal for space is the same: dramatically lower the cost of getting things and people into orbit and beyond.
Like the Space Shuttle tried to do.
Exactly. The shuttle was partially reusable, of course. Its main engines, the SSMEs, are probably the best example of a truly demonstrated reusable rocket engine, flying many, many times over the program's life.
Okay, that promise of lower costs sounds amazing.
Yeah.
Revolutionary, even.
Yeah.
But if it's so obviously beneficial, why isn't everything reusable by now? What are the big hurdles? It can't be easy.
No, it's definitely not easy. And it's not cheap, at least not up front. There's a major hurdle, the high initial investment. Designing for reusability is incredibly complex. Historically, performance getting the most payload up was prioritized over operability. You know, how easy it is to maintain and turn around quickly. Then you have the sheer brutality of reentry. Surviving that requires really robust structures, heavy thermal protection systems, extra propellant for deorbiting and maneuvering. All that adds weight and complexity.
The weight penalty.
Exactly. And the Space Shuttle main engine, the SSME, is the classic example of the challenge. It only fired for about 8.5 minutes per flight.
Just 8.5 minutes.
Right. But after every single flight, it required something like 20,000 hours of inspection, maintenance, and refurbishment labor. It took 2 to 3 months to get them ready again.
20,000 hours of work for 8 minutes of flight. That sounds almost unsustainable. What does that tell us about how they approached shuttle design, and how do we fix that going forward?
It tells us performance was king, and operability was, well, an afterthought maybe, or at least a much lower priority. So how do we overcome that? Based on decades of experience, including the X-37B, several things are key. First, reusability and operability, easy maintenance, fast turnaround. They have to be primary design goals right from the very start, not just bolted on later. The target turnaround shouldn't be months. It should be days, maybe even hours eventually. Aircraft-like operations.
Aircraft-like, okay.
Second, you need continuous testing combined with data from actual flights to keep improving reliability, incrementally making things better, like they did with the SSME over its 40-year life. Third, minimize the post-flight work. That's huge. Build in things like integrated health monitoring sensors that tell you what needs attention without tearing everything apart.
Smart systems.
Yeah. Use more standard off-the-shelf parts where possible. And propellant choice matters. Cleaner burning fuels, like those used in some modern Oxrich cycle engines, leave fewer deposits, meaning less cleaning, simpler maintenance.
So designing for easier maintenance, almost like working on a car instead of, well, a space shuttle engine. What else?
Exactly. Fourth, easy access. Put the components most likely to need work where you can actually get to them easily. Use quick disconnect fittings instead of hundreds of bolts. Think smarter about assembly and disassembly. Fifth, recovery matters. Avoid splashing down in salt water if you can. Saltwater corrosion is a nightmare for reusable hardware. Landings are much preferred, even though you pay a weight penalty for landing gear and wings or whatever system you use.
Landings like X-37B and Starship.
Right. Sixth, design for longer life. Improve the components with the highest failure rates. Turbopumps are often a big one in rocket engines. And consider derating engines.
Derating. Running them at lower power.
Yeah, running them a bit below their maximum theoretical thrust. It reduces stress, increases reliability, extends the engine's life, and cuts down on maintenance. And finally, maybe embrace evolutionary design rather than always trying for something completely revolutionary. Build on proven designs, make incremental improvements. That's how the SSME eventually achieved incredible reliability, like 0.998 through decades of step-by-step upgrades.
Wow. What a journey we've taken. Through the knowns, the unknowns, the theories, and the future possibilities surrounding this vehicle. The X-37B, it seems, with his blend of, yes, mystery, but also cutting-edge reusability, isn't just some military secret squirrel project. It's a real-world laboratory. It's actively shaping how we'll operate in space for decades, affecting everything from science experiments to logistics to understanding what others might be capable of.
Absolutely. This deep dive, I think, really shows that while it's probably not a space bomber waiting to strike, its true value is immense. It lies in that persistent, adaptable presence in orbit, and especially that unique ability to bring things home. It's proving out the technologies, the operational concepts that will hopefully make space more accessible, more resilient, and ultimately more useful for all of us down here on Earth.
A fascinating look at a vehicle that's still got plenty of secrets. Remember, the universe is packed with these kinds of puzzles, just waiting for us to explore them. So here's a thought to leave you with. What new secrets, what new possibilities do you think reusable space planes like the X-37B and maybe its successors will unlock for us in the years to come?